All right, good morning, e-learners. We just had a practice fire drill, so we're going to pick it up from homework corrections.
Yay. Wait, weren't they supposed to do a fire drill?
We have to do some sort of drill once every, so the three, that's actually called an evacuation drill. It doesn't, even though we say fire drill, that's just you're practicing leaving the building in case of emergency. And then there's, lock out, lock in, that sort of thing.
What about lockdown?
Yeah, those words are depending upon who you hear it from, they use different types of words. So is the threat outside or is the threat inside of the type?
Never done a lock in.
Well, so if the threat is outside, right, we lock out, we lock them out, right? If the threat is inside, we call it lockdown, right? But it's because the threat's on the inside. And that's the one where we, turn all the lights and act like we're not in here. But the reality is for those type of drills is that we use some common sense. If we see that there's a threat, we're going to probably evacuate everything. I would hope. Yes?
What did they do with this?
Oh, if you start getting into the what ifs, you can really cause yourself a headache, because you certainly can, having a good plan, a general plan in place is important, but trying to plan for each specific little thing. Well, they could put up tripwire in the hallway, and then people would trip, and there's lots of things. So you try to have a good solid plan that covers your basics, and then you try to use common sense, right, to make good decisions. For instance, we just walked in that direction. Well, if the fire is over there, right, are we going to walk in that direction? Heck no. We'll walk in the other direction. All right. Let's get back to homework. Exactly. All right.
I just have one of a lockdown because they just literally and they know we're here.
You need to have a general plan for many things, and that's
Well,
one
not
of
the
things.
window. I can still go.
All right, quiet, please. Let's get back on task here. All right. We left off with the question. Was your question answered? Okay. Anyone else? Yes.
19F.
Let's take a look at 19F. So 19 has a bunch of different, a bunch of different things going there. There was an F portion of it. We don't know the names of these shapes yet, so I can't call them by their things, but we know what segments are, we know what points are. So F culminates in the fact that it says this. It says how many segments can be drawn between endpoints. Endpoints just represents an unknown shape, right, that has n number of points on it. No three of which are collinear. So they were really trying to tease out. F was the one that you probably weren't going to get. Well, it turns out there's a pattern forming there. The pattern is that if you have 3 segments, right, 3 points. 4 segments, you wind up with 4 points. 5 segments, right? But then you got to start counting the internal ones. So it turns out that with we can't call it a quadrilateral yet because I haven't defined what a quadrilateral is. But on B, it's made for 4 points, but you can have 6 segments. So it looks like it just went up by 2. But then you look at C, which is you can't call it a pentagon yet because we don't know what a pentagon is. We know it has 5 segments. When you play the inside ones, you wind up with 10 total segments, right? There's 10 total segments. You count those segments. So it's not going up by 2. Now it looks like it's being multiplied. Long story short, the pattern, and it was a hard one, the pattern is n times n minus 1 divided by 2. Now, could you have gotten that? Kind of iffy. I don't even expect my honors kids to pick that pattern, but that's the actual answer. So let's see. D, which was, we don't know what a hexagon is, but it's got 6 points, and it's got 15 segments. So 6 points, and it leads to 15 segments. So we let 6 equal to n. We haven't, remember in geometry, until I define what it is, we don't know what it is. We start from scratch. We know nothing. Agreed, but we haven't defined that yet. You will write it in your notes. All right, so that shape that has 1, 2, 3, 4, 5, 6, right? And we play connect the dots. Well, that's got 6 sides, but then you can do your internal connections right there, right? Well, it turns out if you make all of them, well, this can also go to that one, can also go to this one, this can go to this one, this can go to that one. They'll leave one off. think that's all of them. Turns out there's 15 of these segments I just drew. And the way you get to 15 is we start off with 6 sides. So 6 minus 1 is 5. 6 times 5 is 30. 30 divided by 2 is 15. That's where that comes. So F is like a great if you notice the pattern. If not, you know, we'll be okay without F. I would expect you guys to get all A through E though. All right, anyone else? That is, I mean, if you think of that as it being in 3 dimensions, sure, right? So what is a, well, no, I'll take that back. That's not true either. Okay, I'm lost in thought right now. Any other questions? All right, let's grade this thing. 13, yes or no? All right, it sounds like half the class saying yes and half the class saying no.
No.
2 points both lie in each of 2 lines. 2 points, we'll call that AB. Clearly, how many lines can you draw through that?
No.
1. It says 2 points lie in 2 different lines.
No.
The only way you make that happen is if your line, your second line curves. So that one's a no. All right. 3 points all lie in each of 2 planes. You really want to say no.
Yeah.
But the answer is yes, because it doesn't say non-collinear. Think about it. 3 points are on a line, infinite number of planes contained. That is a hard one. That is probably on the test. That is probably on the test. Now, I could change that to 3 non-collinear points. How many planes? 1. But if I just say 3 points, how many planes? It could be infinite. Doesn't mean if it is infinite, but it could be if the points are collinear, infinite. If they're not collinear, then 1. That one's a tricky one. 15, yes or no? 3 non-collinear points all lie in 2 planes. If they're non-collinear, you just said it. There's only 1 plane. Right, so that one is absolutely a no. 16. 16? No one wants to argue for no? No. Good, because you got it right. It is yes. All right, that's good. Those yes and no ones are, you know, you think true, false. Oh, those are never the easy ones. I mean, why does the teacher put a true, false, or yes, no? Is because there must be a trick there somewhere. All right, 17. A is the one postulate says that through any 3 points there's at least 1 plane. What was that? 8, 7, 7.
20 completely.
Yeah. That was 7. B, you gotta check your drawing. C is it's a yes or no. Yeah. It is yes. D. State the postulate that guarantees that line TP exists. There are any 2 points. How many lines are there? Exactly 1. Which one is that? 6. That is 6. You guys are killing it. I was at D. All right. E. State what postulate guarantees that if you have a line, it's on the plane. Actually, if you have 2 points, then the line through the 2 points is on the plane. What's that? Postulate 8. 2 points are on a plane, and the line that connects those 2 points is also on the plane. All right, we already did 18, and we did 19, so all we have left is 20. 20, part A is postulate 5. Then there is at least, this is part B, then there is at least 1 plane X that contains points PR and S. Y? Once again, that is postulate, I got to flip over. Which one through? That's postulate 7. Yeah, through any 3 non-collinear points, exactly 1 plane. That was B. C. What is the postulate guarantees that plane X contains line K? That was the same one that we literally just did. That is postulate 8. C. What postulate guarantees that plane X contains? Oh, I'm sorry, I just did that. And then D. There can't be another plane that contains point P and line K because then 2 planes would contain non-collinear points PR and S. What postulate does that for any three non-collinear points. They're exactly one plane. That is postulate 7. Oh, by the way, you just proved theorem 1-2, which basically says if you have a line and a point not on the plane, then one point not on the line, I said that backwards, then one plane covers both. And that's all she wrote. All right. What's your question? That was 20. Remember I said number 20 is how we prove theorem 1-2. You have a line, a point on a plane, then one plane is contained with both the point and the plane. Point and the line. Can't talk today. Oh. All right. At some point, that needs to go into this box over here. So if you want to pass this around, that's fine. Here was my thought. The practice test that I have you is pretty short, but I wanted to give you some extra practice with 9:30. Okay, yeah, I've got plenty of time. So what I want you to do is grab your books. If you don't have a book, scoot up next to someone that does. And I want you guys to look at page 31. Page 31.
Oh, no, let's do that.
Page 31. I'm sorry, I lied. Page 30.
Oh,
Page 31 is your homework. Let me change this. Page 30. So there's some questions there that I like that are probably on the test, and there's some questions there I don't like. And we're going to skip those. So the first 2 questions, don't like them. First 4 questions, don't like them. So we're gonna go right to 5. Here's what I want us to do. So I'm going to read the question, right? You're going to think about it for a second, and then we're going to talk about it, right? Some of these are going to be really simple. Some of these are going to be way more challenging. So I'm going to read number 5, and then you're going to think about it. So it says points A, B, C, and D are coplanar, but A, B, and C are the only 3 points that are collinear. What would that look like? What would that look like? You guys think you can draw that right now? All right, draw it. It says A, B, C, and D are coplanar, but just A, B, and C are collinear. This is a good test question. Now, the people that are on it probably are already done. There's other people that are still thinking. So let me try to help the people that are still thinking. What does coplanar mean, Karis? That what? Coplanar. What's planar mean? They're on a plane. Coplanar means they're all on the same plane. So my suggestion, draw a plane. Don't label it yet. There's my plane. Just remember, this isn't really a plane, right? It's parallelogram. You haven't defined parallelogram. Goes on forever. Flat surface. So it says points A, B, C, and D are coplanar. So I need 4 points labeled A, B, C, and D on this plane. Does it matter where we put them? So far, it doesn't matter. Let's just put 4 points. 1, 2, 3, 4. You could have chose the corners. Remember, there's really no corners of a plane. A, B, C, and D. Do you agree that those 4 points are now coplanar? Chandler, give me something. Where would I draw a point that's not on this plane? Anywhere off or on the outside of this. Everybody got that basic concept? Okay, so coplanar. But statement 2 gives us some more information. It says A, B, and C are the only 3 that are collinear. Karis, what does collinear mean? So I need to put points on one line, and I need to put points A, B, and C on the same line. Can you do that with the way I drew it? No. So which point do you want me to move? Which one? D? Remember, the first statement says that all 4 points are coplanar. They're great. They are coplanar. So they got to stay on the plane. but it says A, B, and C are collinear. So let's move A to where? One way to do it would be to already have the line drawn, right? And then put A on it. There you go. That's not the only way you could have done it, but there's question number 5. Is yours kind of like mine?
Sí, señor.
Could you do that for a test?
Sí.
Okay. All right. We're on to number 6. Remember, we're drawing this. Line L intersects plane X at point P. Line L intersects plane X at point P. See if you can draw that. Line X intersects plane. Line L intersects plane X at point P. Sorry if I said that backwards. Chris, what was the first shape you drew? The line or the plane? The what? The points? Which point did I draw?
Talk about number 5.
We're talking about number 6 now. Line L intersects plane X and point P. Which one did you draw first? The line, the point, or the plane? I would agree. If there's a plane involved, not saying this is always 99.9% of the time, right? It seems like drawing the plane first would be easy. So I'm going to draw the plane. What's the name of the plane, Chris? Number 6? X. So I'm going to put an X. Remember, that's just the name of it. It's just kind of floating there, that X all by itself. All right, Chris, we're going to draw the point or the line next. All right, where does the line, what's its relationship to the plane? So it's got to go through it. Remember me grabbing a piece of paper and punching a hole in it?
Yeah.
That's the idea. So different color. I'm going to go above it. I intersect, dot, 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 solid.
Well, yeah.
The dot, 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 remember, would be underneath. You wouldn't be able to see it, right? We got one thing left, or 2 things. We got a label, right? What's the name of this line? L. And then one thing left. Where does it intersect at? Right smack there. What's the name of it? And we're done. Yeah, Seth?
So we have a postulate saying that when 2 lines intersect to make a plane, and when 2 planes intersect to get a line, but we don't have anything about a line and a plane intersecting to get a point.
We don't. You want to make this a Seth postulate?
Postulate.
Okay, the Seth postulate says this. When a plane and a line are non-coplanar, then they always intersect. Finish it.
At a point.
At one point. There you go. We'll now call that the Seth postulate. We're going to call that a postulate because do we need to prove that? Or does that intuitively make sense? That's why we're going to call it a postulate. Okay, there you go. All right, number 7. Plane M contains intersecting lines J and K. This is also a postulate, what? This is postulate. No.
Oh, no.
Oh, this is theorem 1.3.
Yeah.
This is theorem 1.3. Now you kind of see why you need a book of truth. You're not going to remember these numbers, even though you know it's a postulate or theorem. You go, I don't remember what it is, and I'm the teacher, right? All right, we're going to go back to what I asked Chris. What do you want to draw first? The intersecting lines? Or you want to draw the plane? I'm going to recommend, unless until we get to one example that it's not true, draw your plane first. Does this plane have a name? M. And then we need what? 2 intersecting lines? Are the lines going to be on the inside or the outside? How do we know they're on the inside?
Says.
Plane M, what word tells us they're on the inside? Contains, right? So 2 lines, it doesn't matter. There you go. There's my 2 lines. I know they're lines because there's arrows on it. And we got to label what? J and K. So J, K. Italicize or cursive, either one's fine. All right. Let's skip to number 9. Let's skip to number 9. Skip to number 9. So we're not sketching or drawing. All right, Jenna, read it.
Name a point on ST.
On what?
Oh, sorry.
Name a point on. Look at it. Look at it. You said ST, and I said, on what? Don't look at me. Look at what you're pointing at. On.
Line ST.
If that's a line, what should be the indicator that it's a line? Don't look at me. Look at your finger. Does it have 2 arrows? So it's not line ST. It's. If it's a segment, it's not going to have any arrows. What's the name of that thing? It's got. Okay. See why your book of truth can come and save your butt? Because if you forget what that is, you could flip back and wait, where did we make? Oh, it's a ray, ST. That ray starts at what letter? S or T? Perfect. Remember, the first letter is where the ray starts. T is the direction that it goes in forever. Okay, keep reading.
ST that is not on
Is that line?
segment ST.
Perfect. Okay. So give me a point that is on ray ST, but is not on segment ST. Now you got to think about what's the definition of both of those things. I'm on ray ST, but I'm not on segment ST. What's special about array? What's special about array? Look at me. I'm a segment between my 2 fingers. What's special about array? It goes on forever. It does not stop. If you're on segment ST, you're somewhere between my 2 fingers. If you're on ray ST, you're from here until infinity, right? And I look at the number line. Give me something that's on the ray ST, but it's not on the segment ST. Where does the ray start? Where does it go? Doesn't go to T, it goes to the left or right. You're correct for saying it does go to T. I just want you to think about this. It goes to the right forever. Where does ST, segment ST, stop? So one of them goes forever, one of them stops. So if it stops right here, give me something over here. Am I pointing in the right direction? Am I pointing in the wrong direction for this example?
Well, for you, you're pointing in the right direction. For us, it's right.
Okay, so here's ST. Here's ray ST. If I'm over here, am I on segment ST? So give me something over here. What? Done. We also could have said, no.
R is in the wrong direction.
R is on both of those. No, he's right. We're all wrong. 1 point for Matt.
What?
Isn't it ray
No.
ST?
ST, so it starts at
Yeah, so he's right at R. He's right at R is
What?
R is on neither. Neither.
Oh, so you're technically right.
You're technically wrong. No, it says I have to be on ray ST.
Oh, yeah.
Right. R is on neither.
It's like Reese.
Right. So
It makes sense.
I could certainly have written that question. Give me a point that is on neither. That would be a good question. All right, Jenna, confident or you're scared now? I would be scared, right? Right. We got to have those that content solid. Like the idea that lines go on forever in opposite directions. Ray only go in one direction. That I would think that would be a perfectly good question to ask you guys, right? So you might want to put that one in your notes or your resource card or whatever. What? Okay. Now we come to you guys have heard the word pedantic before?
No.
Pedantic is a fancy name for someone being a stickler for details.
I don't.
So Seth is pedantic at times. Okay.
Always have it in.
So remember in geometry, when we get a stickler for details, pedantic, right? That is when you got to look at, like I was doing with Jenna, hey, look at it. Is that a ray, line, or a segment? So I want you to look at number 10 and tell me, is that the name or is that asking me the distance? Is that the name, or is it asking me the distance? Wes? It's the distance.
Oh, I thought you had put like that.
Remember, if I take the segment off, then it's asking for the distance. You also notice there's an equal sign. That's your second hint that they're asking for distance. Hey, everybody look at me. This question is on the test. Like the other ones, maybe, maybe not, or there's ones like it. This question is on the test. It certainly won't be exactly like this, but I will put 2 letters with nothing over the top and an equal sign. I'm looking for a distance. All right, Wes, try it. Complete. RS is equal to what? How far is it from R to S?
Wait.
Literally, I'm talking about distance. You gotta look at the number line.
Oh,
How far is it?
3.
Where are you getting a 3 from R to S? I'm doing a teacher thing. He's like, yeah, it's 3. How do I know it's 3? It looks like there's only 1 dot. How do I know it's 3?
You guys, one of those type ones.
That was postulate number 2, which said that, postulate number 1, which said if you want to find the distance between any 2 points, you subtract their coordinates. -5 minus -2 is, and take the absolute value, and to take the absolute value is, so he was right when he said 3. Everybody take a look at that. I probably won't do it as silly as they did, which was, and if I would put it on a number line, my numbers are going to be on a number line, like 1, 2, 3, 4, or -1, -2. They're really trying to mess with you right there. Could you do that one on your own? Because I'm telling you, this one is on the test. Okay. Who's lost on that? Tell me how far it is from S to T. That's the next part of the question. From S to T, how far is it? Okay, do you see the numbers?
Is it 1?
Do you see the numbers, Madison?
That's right.
So how far is it, if that was a number line, from that first number on the right to that next number on the left? I did it backwards again. First number on the right to the next number on the left. Where are you getting a 3 from? Tell me, first off, tell me what the 2 numbers are for S and T. -2 and 1. So nice, easy, friendly numbers, right? Like 7th grade numbers, right? If I told you you're at 7 and you're walking to this point, how far is it? Okay. How did you calculate that? It is 3, by the way. How did you calculate that mathematically? What did you do? You do what? You subtracted. The only difference now is that now it's what, -2 and 1? It's -2 and 1. Subtract and take the absolute value. Tell me what I'm asking you to do. Subtract and take the absolute value. Now tell me what I'm asking you to do. I'm asking you, what was the first word I said? Subtract. Tell me what to subtract. Say again? So tell me what to write. Okay, 1 minus -2. And then we're supposed to take the absolute value. 2 negatives turn into a, right? Therefore, it's final answer. Good. Anybody else? Right? Was that pedantic enough? Right? Way too many details. I'm just saying, this is a pretty easy concept. I give you a number line. I give you 2 points and ask you how far it is between 2 letters or 2 names of, or 2 points that are on that. You've got to be able to do this. If the numbers are positive, there's going to be no one that even gives us a second thought. As soon as I throw some negative numbers up there, all of a sudden, whoo, the train comes to a halt, and all of a sudden I can literally hear the gears turning in your head, and you're unwilling to, you know, literally do it exactly the same way, which she did it both ways perfectly fine. Okay, yeah.
I must say, since we're throwing around big words, like whatever you called me, I must throw
Pedantic.
around, I must throw around my own big word. Whatever to give it.
Okay.
What is a rat for?
All right.
It means a flying,
We're-
irresponsible person.
Okay. Thank you, Seth. All right. Let's do number 11. All right. We have not spent a lot of time on this word, so I'm going to tell it to you. Number 11 says that, is that the name or the distance if it has the line over the top? That's the name. So RS and ST, let's see, the previous problem we just found that RS was 3, and ST was 3. So they have the same or different distances, or lengths, I should say. They have exactly the same. If you have two segments, listen to me. You have two segments that have exactly the same distance. We have a fancy word for that. We don't say they're equal. We say they're congruent. We okay with that word? Congruent? We are going to be crazy okay because we're going to use that word from chapter 2 onward so many times you'll be sick of congruency. Okay. If you have a line over the top, we don't put equal. We say congruent. So it's the equal sign with the one tilde over the top of it. All right. Let's take a look now at 13. Oh, we got to do 12, midpoint. What does midpoint mean? It's in the middle of a segment, right? All right, so number 12 says, if U is the midpoint of TV. So that means between T and V, the smack dab middle is U, right? Find the value of X. Where is X? If U is the midpoint of TV, find the value of X. Well, X is underneath the letter V, underneath the point V, yes? Okay. So how far is it from T to U? Karis, look at page. How far is it from T to U? How far? Where are you getting 3 from? 4. So therefore, what number should I put underneath V? If U is the middle, and you just said it's 4 from T to U, then to go from U to V, it also must be 4, because it was the middle, right? If I'm in the middle of my two arms, which hopefully I am, right? And it's 4 from my fingertip to the middle of my nose, and then my nose is the middle, then it must be 4 from here to here, right? So the problem is I don't have the number right here. I know that this number smack dab here is U, look at your book, is 5. So what number am I going to put underneath U? I'm sorry, under V, sorry. Say again? 2 endpoints and a middle. Nice, friendly numbers, right? If this is 2, and this is 6, right? And this is the middle, right? How far is it from here to here? That's 4, therefore this must also be, I can't write 4 right here, it's not number 4, it must be what? 4 bigger than 6, which would be, now do that same thing for our problem. Can you do that tomorrow? You're going to have to. That one will be on the test as well. Okay? All right. Angles. Remember, we have what? 4 ways of naming angles. If the angle's floating all by itself, you can always call it by its vertex, right? The part where the 2 rays come together, right? We have 3 other ways. If it has a number, right, we can call it by that number. And then lastly, we can use the 3 letters. If you use the 3 letters, what's always the middle letter? The vertex. Now, clearly the people that already know this, they told me the answer. I'm worried about the people that were just silent. The 3-letter one is the one that will get you into trouble. The middle letter has to be the vertex, where the 2 rays come together. That's the vertex, right? Tell me now if you're lost on that, because that will be on the test tomorrow. And it won't be just name the angle. I will use that name in order to generate a question. All right, so let's look at 14. If you have the letter M next to an angle, what is that telling me? The measurement. It's asked me on number 14A, it's saying how big is angle CBD? Take your finger, take your pencil, if you use your pencil erase, lightly trace CBD so that you can see where that angle is. CBD, remember B is always your vertex. So that's the angle. It's unnamed, right? There's no indicator in the book of what it is. But we do know that the angle next to it is how big? How big is it?
88 degrees.
You see where it says 88 degrees? Now we're going to use that one piece of information that we know about straight lines, which is the bottom of that triangle, even though we don't know it's a triangle yet. How many degrees in a straight line?
180.
We know from here to here is always 180 degrees. The only difference in ours is we have this line right here, and we're told that this is 88 degrees. So the question is, how big is that sucker right there? Just tell me what you're going to do mathematically. What are you going to do mathematically to calculate that? From, and that's where you're going to get your answer. Did you ever hear Madison? Connor, what'd she say? Okay, could you make a mistake on that? Yeah, you can make a silly mistake. Show me that you're subtracting from 180, and even if you make a silly math mistake, I'll give you credit for it. You know, I'll take the point off for bad math. But you got to show me you know what's going on. All right. Enough of that. Perfectly. Your homework tonight, and I do want to give you the answers. Write this down. On page 31 is literally what's called the chapter test. Your homework tonight is to take this chapter test. Those of you that have had my class know that I give the answers to all practice tests. Right? It's not called the practice test, it's just called the chapter test. I'm using what's on page 31 as your practice. We still have 2 minutes. Remember, we have 2 minutes after the bell. So, everybody sit. 2 minutes.
The Y's are due.
So, look at what's on the board.
I'll join tonight.
What does it say to do? It doesn't say to do all of them, it says to do what numbers? Now, I do have all the answers on the sheet of paper, but I don't need you to do questions 1 and 2. 1 and 2 I actually did not cover. I chose not to do that this year. You'll be okay. All right. If tomorrow you're trying to, look at me, you're trying to do something with a 3-dimensional shape, and you're like, I just can't wrap my head around it. Can I play with one of those things to look at? You know, while I'm taking the test, you absolutely can. Questions? All right. Don't blow this off. See you guys tomorrow. You may leave. All right, e-learners, your test, obviously I'll post it next class, will be on the bottom of the Google Forms. You will see a link to it for you to take your tests.
Wait, did you send me?